but it's not quite fair, Jans. I think it's I'll say it because you won't. You're one of the founders of this field.
Huh?
One of the founders of the field of knowledge graphs, and one of the main drivers, one of my mentors, and I'm really happy to have you here to talk about some of your work and applying knowledge graphs in healthcare. So thank you.
Okay, thank you. My identity is still psychologist and not computer scientist, but okay. I was going to give a talk called Building a Healthcare and Life Science Knowledge Graph, and without my knowledge, our sales guy Craig added with ChatGPT, right? So, and he told me that last Thursday. Anyway, so but it's fun. I mean, I could talk all day about ChatGPT. So, this is actually two talks. One of them is a plug-and-play healthcare knowledge graph that we built for hospitals. It's so hard to convince hospitals to build a knowledge graph, and you can have all the services you want, but they have to be convinced first. So we built a plug-and-play knowledge graph with Synthea in there for realistic healthcare data, all the taxonomies you want, huge library of example questions and methods, right? And that makes it way easier to just give it to someone so they can start playing with a Jupyter notebook. Anyway, so that is the first thing. And the second is LLMs. So, oh, this is back, right? This one here. We do a lot of work with LLMs in call center analytics, where we take conversations between agents and customers, and where we get insights out of conversations. And ChatGPT is, well, GPT is just amazing for that, right? We also started using it big time for our healthcare knowledge graph, and I'm going to talk about that too. I think I'll only get to the first 2 or 3. That's it for today. And if we have some time left, if we don't have, I could talk about how I filled a complete knowledge graph with wine, a wine knowledge graph, automatically using LLM. But anyway, okay, let me go just straight and not lose time. So for years, we worked with the big hospital in the Bronx, Montefiore, and we helped them build big knowledge graphs in huge scale, and we learned an incredible amount, right? And we're very proud that in 2021, we were chosen as one of the top data fabrics in this space of data fabrics and hospitals. So, I mean, so we know what to do, right, in healthcare, especially hospitals, let me say it that way. And we use this model that we call the entity event knowledge graph, where we say, well, in the domain of healthcare, but this applies to many domains, you have one core entity, and then anything that happens to the patient over time becomes a simple object. We call it an event object with a type, a start time, end time, and a few key value pairs to describe that particular event, all attached to the patient and then logically grouped so you can shard it over a cluster of machines. And then, of course, everything in your knowledge graph needs to be terminated in taxonomies, right? And so we got this down. This is the typical picture that I like to show, where you have your, no, where's the thingy? Oh, here. No, go back. Right, here's your entity. Then you have events. Can we go from all the way from demographics to any kind anything that happens within the hospital with the patients, and then ultimately terminating into your knowledge bases. And so that's kind of the core of the entity event knowledge graphs that we're building. And then I can talk about many different benefits, but I think the main benefit of having a knowledge graph in healthcare is that your queries become roughly 100 times more simple to write and to understand, right? So that's one. And the other thing that I talk about a lot is, if you try in a hospital to say, give me everything about Deborah McGinnis, they laugh at you, right? But because you're in too many databases, you're probably in 1,000 databases. But once you got it in a knowledge graph, it's one click, one line, and you got the beautiful JSON object that describes you, right? Anyway, so as I said in the beginning, so you have this beautiful knowledge graph, but how can you show this knowledge graph if all the data in your knowledge graph is protected, right? You can't appear all the personal health information, you can't share it. There was a huge problem that we had, so we finally decided, okay, we're just going to build an entire one using Synthea. Who has played with Synthea in this audience? Okay, so there's one. You might have done some of that. Yeah, so really stunned with how good it is. I mean, some things are missing. And Mimic 2 has some more stuff about ICU data, but still it's a really good data set if you want to start, right? And so we built this thing here where we have, well, what we found, the most important thing is I can now give it to someone in a hospital that then can show it to the leadership and to their colleagues, right? To kind of show, okay, what can I do with a knowledge graph in a hospital? Now, the big hospitals in the United States already are building them. There's so many hospitals, right, that they don't even know where to start. So that is the first thing. A complete plug-and-play knowledge graph that you can show to your colleagues. And then we have this library for literally almost anything that a hospital cares about, right? Standard reporting. You have the CMS quality reporting for Medicare, Medicaid. You have, if you want to do entity prediction, right? We can, with one line, get all the events for a person, and you can feed it to machine learning algorithms to do event prediction, feature extraction, claim reporting. So Synthea has claims data, so we have a lot of queries around computing claims. Cohort selection, similarity search, it's all in our set, in our library to kind of start going. Then the data sets, well, it's Synthea, it is everything in UMLS. It's the FIRES database, you know, that vaccine advanced reverse, sorry, what's the, anyway, the vaccine database. And we have a lot of PubMed articles in there, just as an example of what you can do with this, all integrated. And I'll show you in a second how we do that. And then very important, almost every hospital that we talk to wants security, right? They want to make sure that you put all the data in one place, but now how do you protect your data, right? Instead of, and you can't put it in different repositories that you save, but you have this one big database. How do I protect certain parts from certain people? So we have several mechanisms to do that, and we implemented that already as an example in our knowledge graph. So they can see it's a really, really safe knowledge graph. Then people say, yeah, but I have 10 million patients, will that scale? So we have a data set from Synthea running on a cluster of 12 machines where we run about 10 million patients using Synthea data. And all our libraries work with that big data set. And then, of course, the question is, can I use my own data? And that's, of course, the whole point for us, to help hospitals build their own data into this knowledge graph. So this is the picture of the data sets. We have UMLS in the middle. We have, well, all these parts of UMLS that you would expect, including the semantic network. And then one of the speakers this morning told us that 80% of all the medical data is unstructured, right? Well, in our data set, it definitely is the case. So we use BioBird for entity extraction and our own UMLS mapping system. So we take articles from PubMed, we take the unstructured text in the clinical trials, we take the FIRES database unstructured text, although there's not much in there, and then we have the text in Synthea itself, all linked together via UMLS. So now it's all big one system. And so now if you look at our graph, let's see if I can do it here, right? So this is kind of the graph that I showed in the beginning. It's the medical records, just a few fields in this case, right? Linked to UMLS. And then there's clinical trials that we also use to the UMLS. So now you can link patients to clinical trials. So now, for example, we can say for a particular kind of patient, okay, find me clinical trials that are relevant, or given a clinical trial, find me patients that might be relevant, right? So, and there's examples in our notebooks to do that query. And then we have the course 19 to the PubMed literature, again, linked to everything else, and then the FIRES database, right? So it's a knowledge graph that literally, through the unstructured text, links everything together. Okay, so now for the fun part of the meeting, of this talk. So who's using LLM for healthcare data? You are? And you, okay. So, I've been for a long time really interested in causal graphs, yeah, using Bayesian statistics or just taking text and trying to find causal relationships, and it was always so hard, right? We were building rule-based systems to extract it. We worked for a long time for the Stanford Research Institute, where they were taking you remember that probably, right? The Biology 101 textbook, right? We had 30 people basically annotating every chapter in that book to say this causes this, and this causes this, and this causes this, right? It was a horrible job to do for these people, right? It was really horrible. But now, the amazing thing is that you can just ask GPT, right? So the prompt is, so here's an example of a causal chain from A to B to C, and then you get the adjacent object right here. And then you have used this representation to show a causal chain between COVID-19 and colon cancer. Make sure that each of the URLs point to a real medical article or web page that covers the from A to B, right? So you give it the structure that you want, you ask the question, and you get great results. I mean, so basically, here's one chain, right, where you see from COVID-19 pandemic to disruption in healthcare system, from disruptions in healthcare system to delayed colon cancer screenings, etc., all the way to increased rate of undetected colon cancer, right? Now, there's great results in terms of this, but literally every link, oh, let me go back here. Half the links, right, didn't exist, and the other half was wrong, completely fabricated, right? So that's kind of a bummer. But what we found out is that you can actually use GPT plus web search to correct those mistakes, and that's kind of amazing. But we spend a lot of time always on validating results, even in the wine database that I won't have time for, I guess. But even in the wine database, we always have to do a second or even a third question to get there, right? So in this case, we do the prompt find articles that prove that there is a causal relationship from COVID-19 pandemic to disruptions in healthcare system, right? And then you get 4 links, and we check them manually, right, just to see if this is reasonable. And I always ask for my results as a one single atom, or a Python list, or a JSON object. And if a JSON object, I tell beforehand what the JSON object is that I want to get back, right? Because otherwise I get text, and then GPT doesn't help because I go from text to text, and I still have the same problem, right? Anyway, so you get a list, and then in this case, I mean, they're all real and spectacular, right? So these links. So if I want to show that then in graph, in our visualization tool, right, now I go from COVID-19 to cause. The strength is 4, according to GPT, to this factor, to this factor, to this factor. And I can show then here. And I can attach all the reference, of course, to this, right? And then another part of the art of prompting, right, is how do you ask GPT to do another causal chain, right, that doesn't copy the first one? Because that took me a long time, but I now have figured out how to do this, right? I'm not going to tell you because I want to get the job, right, that you just talked about. But so this is finding causal chains. So another one that I was interested in is how do you find links between, say, increased salt intake and higher blood pressure, right? And so I have this big UMLS database. I can do a shortest path between increased salt intake and increased blood pressure, and I get all the relationships. I get all the relationships in this particular UMLS network, but it's not really causal, right? It's just semantic relationships in terms of words. But the cool thing is, I can also now ask ChatGPT. So I've used, in this case, Sparkle, and I can show in a minute how we did that. I use Sparkle to ask for JSON objects back, given my particular prompt. And so now you have this, I mean, and I hope you can see this here. It's probably a little bit hard to see. Oh yeah, you can see it here. It all links all the way back here. So I got 3 causal chains plus all the UMLS relationships. So, I mean, I don't know with you guys, but I'm kind of completely excited by this, right? Because I can now, there's a million there's a trillion knowledge graphs in ChatGPT, right? It's just a matter of how you get it out and how do you check what you get back is really true. But it's really amazing that you can, in this combination. And this brings me to the point. I'm writing this article. Let me first do the last one. The last use case here. So the other thing is, so we have this knowledge graph that we give to hospitals. And this one hospital said, yeah, but that's great, Jans, but you know what the hardest thing for us is? Medical notes, right? We really need the medical notes. So one of my colleagues who's really, really good with GPT created prompts. So he wrote a program to create prompts that then gives you the answer. So basically, what you see here is a prompt that's actually, it's a query against, oh, Jesus. Yeah, this is here. So this is one of the people, providers in the Synthea. This is one of the patients with her age doing an outpatient encounter in this particular county. And so this is, so you do a Sparkle query, right, to get these parameters. And then you look at the last 5 conditions, the last 5 procedures, the last 5 medications, even the last 5 observations, the findings, the last 5 encounters. And then the rest of the prompt, after examining the patient, Marianne wrote up the following detailed clinical report, noting any observations, recommendations, lab orders, prescriptions, or follow-ups in a narrative or structured style. And he made a misspelling, but ChatGPT doesn't care about that, right? And then you get a medical note, which is kind of, I mean, so my hospital was happy with it. There's doctors here in the room, right? So they might think it's too artificial, but still, it's kind of amazing. And there's recommendations that were not in the original observations. Anyway, so so the premise of this article that I'm writing is that future intelligent applications are really a collaboration between a human being, a very smart human being, right, an LLM, and a knowledge graph. I think these knowledge graphs and LLMs are made for each other, because if you just ask questions and you can't store these questions anywhere, right, then it's fairly fleeting. And you can't say, ask a ChatGPT, okay, so how many, let me go back to wines here. How many wines have high tannins and very low sugar contents and are aging very well, right? That's, it will give you a wishy-washy answer, but if you create a wine knowledge graph, then you actually can, right? So anyway, let me conclude this picture, and then I go to your wine example. So here, yeah. So basically, the conclusion for what I was just trying to say is that a plug-and-play knowledge graph is really a big step forward, right? To get hospitals to think about knowledge graphs, and endless possibilities for LLMs. Okay, so that is the part about my talk, and now about the wine. Here's my wine knowledge graph. So this was created completely automatically, and I'm going to show you a Sparkle query how we do that later, right? Where you have France. Hate that thing. Yeah, so France has 2 regions, some main wines, some what I call individual wines. I need a better word for that, but vintage is only the year, right? So what do you call it? And it's, by the way, not in your ontology. And by the way, this is Deborah's ontology mostly. So here you get this, and then you get that this one has these grapes, these node profiles. What is this, medium high? Anyway, you get my point, right? So this is the knowledge graph that we have. And I'm 100% sure that GPT read Deb's article. 100% sure. There's no way he could not have done that. So I just got back that, right? But I used your ontology, but you missed the note. So you didn't have the tastes that the wine has. So I said, hey, give me the ChatGPT, give me all the taste that an expert uses to describe a wine, right? And I gave you the first 3. There's 3 more, but so you have fruit flavors, herb spice flavors, oak flavors, etc. Right? And then, okay, what kind of grapes do you have? Of course, they need to be objects, right? And then what grapes are there, for example, in Bordeaux? You can ask that too, right? And there's 5, everyone knows that, right? Here. And then I say, usually, give me 200 Bordeaux wines. I did a small example here. And then give me a few examples of these Bordeaux wines. And I get the Chateau Latour Premier Grand Cru 2012, I believe. Anyway, and then I say, okay, describe this wine to me, right? As a JSON object. And I get these tasting notes. But that's way too much work for me. So I said, I made a much bigger prompt where I had to prompt how I wanted to get my results back about the wine, right? And, well, here's a beautiful example. Let me go here. And so here's an example. I mean, this is kind of super cool, right? That you can just construct this. And one of the things you always have to do is you have to force ChatGPT to use your predicates. Otherwise, they vary with this, and then you still have to do the mapping to predicates, right? But anyway, you learn how to do that. Of course, you want to have food pairings for this. And then I wanted reviews. And in the beginning, I asked for reviews, and ChatGPT said, well, I can't give you reviews. We stopped in 2021. I can't look it up. But what I can do is I can make it up, right? Just like a human being, you know it's in the wine and you make it up, right? So this is what it made up. This is a description of the Latour 2012. And by the way, I was in Atlanta 2 weeks ago giving a talk about something else, and I gave this example. He said, okay, let me call. And he called his favorite restaurant, and in the evening, I drank that wine, which is amazing. But so anyway, this is what I call fantasy reviews, right? More like human reviews. And then you can also use the web. So does anyone use here web chat GPT? Well, yeah, but web chat GPT is a plugin that you get into your GPT, right? And basically, you ask a question, it goes to the web, it finds 3, 6, 10 links, whatever you specify. ChatGPT will read it and then answer the original question. Again, you get amazing results if you use that trick. So, so that was that. And then finally, here we've built this. So if our newest version of AllegroGraph comes out real soon, 7.4.0, we have a magic predicate in our Sparkle. So you can see, do a prompt and give me one word back. Do a prompt, give me a Python list back. Do a prompt and give me the JSON object back, right? And so here is a series of, this is, I mean, you can try it out yourself. It will be an example query in our database. You do this set of insert queries, and this is the picture you get when you do it, right? But I think, and then of course, the most important thing is you can't trust anything, right? So you have to do a lot of test queries to see if, once you do a web search, if it actually gave you the answers back. So some people describe old socks as a taste in wine, right? So I say, huh?
Dirty socks.
Well, I wanted to keep it nice. So is old socks one of the many tasting notes for the Chateau Latour? I prefer a yes or no answer. If you're not certain, say I don't know. If you can't find any relevant information, say no information available, right? And this uses web search, and it says, yeah, no information available. And here's even a query where we delete information if the prompt is no, right? So you get your data filled in, and then this is the query where you say delete this data if I can't find it on the web, right? So anyway, that was it. Any questions?
So I think you've set up our panel wonderfully. So maybe what we'll do is take some questions on the first part, and we'll take the rest into the panel.
Hey, great talk. I'm Jan. I'm working for a CPG company. So I have a quick question regarding, you use this to build the knowledge graph. Of course, it will alleviate a lot of the effort require expert to manually craft the ontology, all the things. So the first question is, all the large language models, they trained on, usually there's a cutoff time, let's say, based on the knowledge till 2022.
Mm-hmm.
They are static. How do you incorporate the latest knowledge and also related?
But that's what we now do, right? There's a Python framework called LangChain. There's AutoGPT. There's ChatGPT. Those are systems where you can go to the web, do your search, filter out the Google advertisement links, right? Now you get it, or we use DuckDuckGo. You get a set of links, let ChatGPT read it, and then answer the question. So now this is kind of the stopgap, right, to deal with the fact that these models end at a particular date. And your first question about ontologies, I do not believe that ChatGPT is really good at ontologies. Human beings need to do these ontologies. There's too many complications and issues with the. But once you have an ontology, right, you can use it. And I'm the one thing I'm really excited. And my talk is already gone. But those picture where you have this the causal relationships and the knowledge graph relationship, right? That is, if you really think about it, it's amazing that you can use this knowledge graph to embody both your hard-coded knowledge and your whatever you can get out of GPT or an LLM.
Yeah. So the related question on the second part is the existing knowledge, even the the current training document, right? You use the word fantasy to describe one of the answers, right? A lot of people call this hallucination, right? They simply make up answers. Do you have any thoughts? How do we alleviate? How do we reduce the error rate? Because in medical diagnosis, you wanted to avoid any mistakes, I guess.
Well, I just heard this morning about the 60-30-10 rule. So there's a lot of mistakes going on anyway, right? So I wonder if ChatGPT does way worse than a doctor, right? But the whole point is you have to build a framework where an LLM will generate data, and now you have to test to filter out what is clearly not existing. And then you get a gray area where I don't know what to do, right? But I can't give you a solution, right, where you give the 100% sure answer, because a human being can't do it either, right? I mean,
yeah, that's a fair argument.
Yeah.
Thank you.
All right.
Okay. Any final questions for Jans before we move on to the panel? Or we can pick them up there.
All right.
That's awesome. Thank you, Jans.